Next topic is differentiating electrons. Differentiating electron means the last electron present in subshell is called differentiating electron. For example, in case of nitrogen, this is the last electron, 2p3 electron, that is called differentiating electron. In case of sodium, this is 3s1 electron is called differentiating electron. So what is the differentiation? The electron which lastly enter into the subshell is called differentiating electron. If the differentiating electron enters into S subshell, then it is called S block element, except to helium. Yes, helium electronic configuration 1s2, but helium is present in p block element. Helium comes under p block element, so that is somehow exception. So what is the point? If the differentiating electron enters into S subshell, that is called S block element. If the differentiating electron enters into p subshell, that is called p block element. If the differentiating electron enters into D subshell, that is called D block element. D block element. And if the differentiating electron enters into F subshell, that is called F block element. What is differentiating electron? If the electron which is entered lastly into subshell, that is called differentiating electron. See, nitrogen, in case of nitrogen, this is differentiating electron into P subshell. So that nitrogen is a P block. In case of sodium, differentiating electron enters into S subshell. So that sodium comes under S block element. Next point, if the differentiating electron enters into S subshell or P subshell, if the differentiating electron enters into S subshell or P subshell, then the corresponding principal quantum number indicates period. This is very important point. That means by using differentiating electron, we can find the period number of the element. If the differentiating electron enters into S subshell or P subshell, then the corresponding principal quantum number indicates period. For example, take nitrogen. In case of nitrogen, atomic number 7, its electronic configuration 1s2, 2s2, 2p3. See, in this case, the differentiating electron enters into P subshell. Here the principal quantum number is what? 2. So that nitrogen present in second period. Nitrogen present in second period. Period number is 2. Next, in case of sodium, what is the electron configuration? 1s2, 2s2, 2p6, 3s1. So this is last electron. That is the present in which shell? S subshell. Here, what is the period number? Third period. That means sodium present in third period. So based on differentiating electron, we can say the what? Period number of the element. Next, if the differentiating electron enters into D subshell, then the period number increases by 1 unit of the corresponding principal quantum number. This is also one of the important points. If the differentiating electron enters into either S or P subshell, then corresponding principal quantum number indicates period number. But if the differentiating electron enters into D subshell, then corresponding principal quantum number increases by, then period number increases by 1 unit of corresponding principal quantum number. For example, take chromium. Chromium atomic number 24, its electronic configuration 4s1 3d5, where the differentiating electron enters into D subshell. Here, so chromium comes under D block, that is okay. Here period number is, here n value is how much? 3. But in this case, differentiating electron enters into D subshell. So that we have to add one number. So 3 plus 1, how much? 4. So 4 is what? Period number. Which period number? Chromium period number. That means chromium present in fourth period. Next, if the differentiating electron enters into F subshell, then the period number increases by 2 units of the corresponding principal quantum number. If the differentiating electron enters into F subshell, then period number increases by 2 units. In case of D subshell, period number increases by 1 unit. So like that we can find the period number of period. Like that we can find the period number of any element in the periodic table. Next, to find groups. That means how to find the group number of the element. Group number is calculated by valency electrons. Valency electron. Valency is number of electron. Valency means number of electrons present in outermost shell. Valence electrons means number of electrons present in outermost orbit or outermost shell. If the differentiating electrons enters into S or P subshell, then the group number ends with A. I told you already in periodic table 1A, 1B, 2A, 2B, like that groups are present. So which element comes under A, which element comes under A, B? If the differentiating electrons enters into either S or P subshell, then the group number ends with A. If the differentiating electron enters into D or F subshell, then group number ends with B. For example, take nitrogen atom. Here atomic number is 7. Electron configuration is what? 1s2, 2s2, 2p3. Here how many valence electrons? 5 valence electron. Here the differentiating electron enters into P subshell, so that the group ends with A. So it comes under which group? 5A, because 5 is the valency electrons. 2 plus 3, 5. 5 is the valence electrons. 5A. Why A? Because differentiating electron enters into P subshell. In case of sodium, atomic number 11. Electron configuration 1s2, 2s2, 2p6, 3s1. Here differentiating electron enters into S subshell. So here how many valence electrons? 1 valence electron, 1A. In case of carbon, how many valence electrons? 2 plus 2, 4. Here differentiating electron enters into P subshell, so that 4A. In case of sulfur, electron configuration 1s2, 2s2, 2p6, 3s2, 3p4. So how many valence electrons? 6. Here differentiating electron enters into P subshell, so 6A. So like that we can find group number of any element in the periodic table. Next, if the differentiating electron enters into D or F subshell, then group number ends with B. For example, take chromium. Its electronic configuration, its atomic number 24. This is outer electronic configuration. Argon 4s1, 3d5. So it contains how many valence electrons? 1 plus 5. How many? 6. Here differentiating electron enters into D subshell, so that it ends with B. So chromium comes under which group? 6B group. Chromium comes under 6B group. So simple point here. If the differentiating electron enters into S subshell or P subshell, then group number ends with A. If the differentiating electron enters into D subshell or F subshell, then group number ends with B. If the differentiating electron enters into either S subshell or P subshell, then corresponding principal quantum number indicates period number. If the differentiating electron enters into D subshell, then period number increases by 1 unit of corresponding principal quantum number. In case of F subshell, that means if the differentiating electron enters into F subshell, then period number increases by 2 units of corresponding principal quantum number. Group number is identified by using valency electrons. So this is the way to find period number and group number. Next, note the general electronic configuration of S block elements is ns122, because all 1A group elements having electronic configuration of ns1, all 2A group elements having electronic configuration of ns2. So 1A and 2A both comes under S block, so that the general electronic configuration of S block is ns122. Similarly, the general electronic configuration of P block is ns2np126. P block, that means from 3A to 0 group, 3A, 4A, 5A, 6A, 7A and 0. These are comes under P block elements, so that it's the general electronic configuration ns2np126. The general electronic configuration of D block is ns122n-1d1210. And the general electronic configuration of a block is ns2n-1d021 n-2f1214. So this is all about general electronic configuration of S block, P block, D block, F block. These are very, very important points. These are important in competent level also. Please remember all these points. Next, atomic radius. We discussed already about this one in 10th class. That is, what is the definition? The distance between nucleus and outermost electron present in an atom is called atomic radius. This is also called atomic size. Distance between what? Nucleus, that means center point, and electron present in outermost orbit. That distance only considered as atomic size or atomic radius. Here This atomic radius is classified into three types. They are metallic radius, van der Waals radius, covalent radius. Metallic radius means, see, suppose if two metals are present at adjacent side, if two metals are present like this, then this distance, only this distance is considered as metallic radius. If two atoms are present like this, then what is the metallic radius? This distance or this distance is called what? Metallic radius. Then what about this one? This distance is called internuclear distance. That means the distance between nucleus of one atom to nucleus of another atom, that distance is called internuclear distance. So what is the definition of metallic radius? Half of internuclear distance, between two metal atoms is called metallic radius. So then this is called diameter. So diameter equal to 2 into metallic radius. So this is about metallic radius. Next, covalent radius. Covalent radius means when two atoms are bounded like this, then this distance, that means from here to here, that distance is considered as covalent radius. So what is the definition? This is internuclear distance. So half of the internuclear distance between two atoms when they are joined by covalent bond. This is covalent bond. How can we say that? When two atoms are merged with each other, that is called covalent bond. That means covalent bond is present between those two atoms. Then the half of the internuclear distance is called covalent radius. This length is called bond length, that is also called internuclear distance. So what is the definition of covalent radius? Half of the internuclear distance between two atoms when they are joined by covalent bond is called covalent radius. So bond length equal to 2 into covalent radius. So this is the bond length. This is also called internuclear distance. Next, last one, that is van der Waals radius. So what is the definition? Half of the internuclear distance between two atoms of different molecules. This is one atom, this is another atom. So that distance is called van der Waals radius. So this is about types of types of atomic radius. Thank you.